So
Yeah.
just before we get started tonight, just to let you know that this meeting is being recorded and it is being live streamed to YouTube at the same time. And the recording will, I believe, appear on our website at a later date in time. Just so everybody's aware of that fact.
Cool.
The recording and live streaming at the same time.
So that all the good people who couldn't actually be here tonight will have an opportunity to enjoy the presentations. So
John,
as
the
usual.
floor is yours. We'll ask everybody to turn off their video and their audio at this point in time. And John will get the meeting started.
So wonderful. Thank you so much, Sue. So hi, everyone. It's 7:30 and we're going to begin. Welcome to the October meeting of the Hamilton Amateur Astronomers. For those of you that don't know me, I'm John Govro. It should say that somewhere on the screen there. It should have my name. And I am currently the chair of the Hamilton Amateur Astronomers for at least another half hour or so, right? We'll see how things go later in the meeting, I suppose. So tonight, we have a wonderful guest speaker who I'll be introducing to you in a moment. We have Matthew Mannering, as usual, with the Sky This Month that we all very much look forward to. We have a little later on, we have some of the club business to deal with, and we have some door prizes to hand out later on as well. We save the door prizes for later, so you hang on for the business stuff and you don't just go after Hilding is over, after his talk is over. We save some of that stuff for later on. So welcome to everyone. Delighted you could tune in to tonight. It's a pleasure to virtually see all of these names up there. That's very nice. I'll reiterate before we carry on here. I will reiterate what Sue said. If people could make sure that their mics are muted and that their cameras are turned off, that would be wonderful. That will make things flow much easier for the presentations. And speaking of that said, we'll get to the good stuff here. We'll get to the good stuff, and I'll have opportunity to do announcements in that later. We have a special guest speaker again this month. Dr. Hilding Nielsen is an assistant professor at the University of Toronto. And you know, if I get any of this wrong, you feel free to jump in and correct me, okay? So Dr. Nielsen took his doctorate there after taking his undergrad at St. Mary's in Halifax. Prior to returning to Toronto, he taught at East Tennessee State University and has now taught a variety of courses at U of T, including physics and math of the universe, origin and evolution of the universe, great astronomical issues, which sounds really, really intriguing. His research is focused on the physics of stars, from the nuclear burning core out to the circumstellar medium, where stellar winds interact with interstellar medium, and includes the stellar evolution, structure, and atmospheres of massive stars, including classical Cepheid stars, red giants, and supergiant stars. I stole that directly from his website. Dr. Nielsen is an Indigenous person, and he's brought attention to Indigenous astronomy through what he describes as an effort to embrace and integrate Indigenous knowledges and methodologies to better understand the physics and stars of the universe and our place in it. And it is in this area that he'll be speaking to us tonight, and I couldn't be happier about that. I know that you would all join me in extending a very, very warm welcome to Dr. Hilding Nielsen, and I will turn the floor over to you now.
Well, thank you. I will bring up my slideshow and hopefully I can share it. I hope you all can see something that looks like a keynote slide.
See it perfectly. It's coming through very well.
Excellent. I'm glad to hear it. So thank you very much for inviting me to visit your organization and your meeting, even virtually. It's a great pleasure to be here. Yeah, as was said, I am Indigenous. I am Mi'kmaq. I am from Newfoundland originally. And I just want to acknowledge before I start that we are giving this presentation primarily on the Dish with One Spoon Wampum territory, which is an agreement between the Mississaugas, Haudenosaunee, and Anishinaabe peoples for sharing this land and living on it wisely. I want to spend the next hour talking to you about something probably you're not very used to hearing about from an astronomer. And that's about kind of questioning our axioms and how we do science and thinking about it instead of what I'll call the traditional Western way, thinking about it from Indigenous perspectives. And so in this talk, I want to describe a little bit about how many Indigenous people sort of view the universe and how we relate to it and how that differs from Western tradition. I will share the traditional Mi'kmaq story of Muin and the Seven Bird Hunters and how we learn science and science and astronomy from that. And I'll use that as a background to sort of delve into some of the big questions in astrophysics, primarily, where's all the life out there in the universe? And so this might be a little bit challenging for some of us, especially if we're trained in science and we're used to the scientific method, to step back and maybe think about all these questions from a different perspective. So I hope you can join me on this kind of discussion. So as I noted previously, we're on Indigenous land, and Indigenous peoples have been on this land, Turtle Island, North America, since time immemorial. And part of living on that land is living with nature and the environment, as well as living within the night sky. And so, we could see the abundance of First Nations and Inuit peoples across this land. And as part of that, every people had to live under a sky, observing the stars for about tens of thousands of years. And having that kind of long-term observations and generational memories of all these stars, you learn a lot about astronomy and science in ways that aren't quite as noted in our own Western perspective. And one of the really key issues of this is that where we view the sky really depends on where we are. So to take the extreme example, in the Northern Hemisphere, the phases of the moon look very different if we're lucky enough to hang out in Fiji, as I think one of my colleagues here is doing at the moment. And so when we see this Northern Hemisphere, the phases of the moon are backwards relative to the southern. And so if we're in the north, we would view those phases very differently than from the other hemisphere. So our view of the sky depends on the land we're on. And in that respect, for many Indigenous peoples, what is reflected above what's above is reflected below. For instance, the Lakota and Dakota peoples, primarily in the West, so states of Dakota, Manitoba, etc. The night sky is literally a map of the land. So they can look up at the sky and figure out where to go, where to travel to go home or whatnot. So let me take a few moments now and try to share the story of Muin and the Seven Bird Hunters. This is a traditional Mi'kmaq story. There's one of the few that's publicly known. Because of colonization, many stories have been lost. And the story is very, very powerful story for many people. Sorry. So to discuss the story, we have to be observers, and we have to observe the night sky around a couple hours before dawn every day. Now, I'm not a morning person, so I haven't actually tried this, but I invite you all to try this yourselves. And in doing so, we can tell this story. This is because Muin and Seven Bird Hunters is actually very familiar to us. It is much of the constellation is related to the Big Dipper. And if you view it 2 hours before dawn every day, in the spring, the Big Dipper will have a different angle, as we're all aware, because of the orbit of the Earth around the sun and the change, the 1 degree change in day and night. And so, in the story, Muin, the bear, which is denoted by the 4 stars that we would consider the cup of the Big Dipper, is leaving her hibernation in spring. looking for food. It's been a long winter. Muin is hungry. And the first bird hunter sees Muin in the distance and calls for help because they're going to hunt the bear. And the bear is important for the Mi'kmaq as a source of fat and meat and sustenance. And so the first bird that sees him is Robin. Robin takes the bow and arrow to chase after him, followed by brave Chickadee carrying a birch pot. And you'll notice that if you track back, if the 4 stars of the cup are Muin, the next star in the Big Dipper is Robin, then you have Chickadee carrying the pot, which is 2 stars. We're already seeing a little bit of science here as we would recognize it. And after Chickadee is followed by Gray Jay, Passenger Pigeon, Blue Jay, then Barred Owl, and Saw-Whet Owl. And my thing is very slow. And the birds follow after Muin, and Muin, she runs away because Muin, wants to survive and find food. But in the summer, Muin is running across the land, and the birds are chasing it, and they're trying to find it and hunt it, and they have trouble. And as you get towards autumn and the fall, the birds at the end, like Saw-Whet Owl and Barred Owl, start to fall below the horizon and lose track of the chase. But it's fall. Muin is getting tired and angry. And Muin rears up on its hind legs to scare the Robin and Chickadee and the other birds. But Robin fires an arrow and strikes Muin in the chest. Blood splatters everywhere, all over the leaves, all over the trees, all over Robin. Robin flies into the trees, shakes off its feathers, staining more of the leaves, and leaving, except for one red stain across Robin's chest. Muin, dies from the wound, and the birds come together to gather the meat and celebrate. They come together, they build a fire, they bring the pot, Chickadee brings the pot for the meat. Other birds catch up, and they celebrate and dance and have a festival. The spirit of Muin continues through death, and in the winter, when the Big Dipper is upside down, Muin is on his back waiting for spring, and the cycle begins again. This is the very abridged version of this story. You can find longer versions told online by Elder Mardina Marshall. And I urge you all to look up that story. It's very beautiful when she tells it. And we can think about this story as a way of transmitting knowledge. Almost all knowledge in some respect is a form of storytelling, and there are lessons we can learn about from this particular story about the night sky and nature. And so what might some of them be? Well, let's think about it first from an Indigenous perspective. So I have to first acknowledge there is no pan-Indigenous knowledge system. The Mi'kmaq have one knowledge system, the Haudenosaunee have another, Salish another, Inuit another, Dene Navajo another, so on. But there are many commonalities. I've already noted one, that what is above is reflected below. So what is in the sky is reflected on Earth. Another is that knowledge is relational. Now that's a very different kind of construction than what we're used to in science and astrophysics, which knowledge should be objective. But being relational, that changes the dynamic. Indigenous knowledges are incredibly well suited and well versed at considering multiple variables interacting concurrently. So one of the most amazing stories that I've understood, and I've been growing up in Newfoundland, we had caribou herds all around, and as well as in the northern Quebec and Labrador caribou herds. But scientists cannot predict herd migrations. Every year the herd migration changes a little bit or a lot, depending on what's going on, and it's not predictable. It's because there's so many variables that go into predicting how a caribou herd will migrate across the land or the tundra that it doesn't really fit within, say, computer models. However, Inuit and Innu elders and knowledge keepers, they intuit how the migration will change, and they know how to manipulate it. They've observed migration so many times, and through passing of stories and memory, you create a form of genetic memory, not genetic memory, but a form of genetic memory where they can understand these migrations and know how to work with it. So over this long periods of time, many Indigenous peoples develop ways to understand nonlinear variability. From an astronomer's perspective, we know this as well. In both Anishinaabe stories and various Indigenous Australian stories, they discovered long before Western astronomers pulsating red supergiants. Like they knew Betelgeuse was a pulsating red supergiant long before. Except in Anishinaabe stories, they were beating heartberries. Another thing to consider is knowledge is treated in a holistic sense. Now I use holistic with a W, not in a religious sense, but holistic in that it covers many avenues, many disciplines. You know, I think of astronomy and astrophysics, I think of astrophysics. I think of biology, I think of biology. I think of mathematics, I think mathematics. But much Indigenous knowledge can flow back and forth between different disciplines, what we would call disciplines in the West. And in that respect, we also have, there's a respect for nature that is holy, that is in a sense that is sacred or holy. And I don't dislike those words personally because for many Indigenous peoples, the equivalent actual feeling doesn't really translate very well to sacred or holy. But there is a familiar notion that we're related to nature. The bears are cousins, or the birds are our cousins, hence bird hunters were related. So we have to think about these axioms and how we tell stories and then what we learn from them. So let's think about the story and apply some of those axioms. Well, the first part is the story of the bear is from spring to hunt to winter and repeats again in spring. So the first lesson is life is cyclical. And for the bear, that's true. It also tells us lessons of when we shouldn't be hunting bears. You don't want to hunt bears in the spring or early summer, or in the spring because that's mating season, or in summer because that's when they're starting to fatten up. So you don't hunt bears then, you hunt them towards the fall is the best time. The story tells us about sharing in community. If you watch the video from Mardina Marshall on YouTube, you could actually just Google Muin and the Seven Bird Hunters. She goes into detail about how the bear is shared across between the hunters, how the community all benefits and everybody supports each other. It tells us about guide stars. Because the constellation circles the night sky, it's pointing directly at Polaris or Mi'kmaq Dudapin. And it tells us the nature of bears and birds and leaves and all these things. Now, it's not a factual if X then Y kind of translation, but it gives us the knowledge related to where we are on that land. And for this story, we're more or less in what we would call today Nova Scotia, New Brunswick. And so this is where I have to have a rant. I apologize up front, but this is my pet peeve when thinking about this story, Muin. And that is, why in Western astronomy does Ursa Major have a expletive deleted tail? The Greek story of Ursa Major, apparently, and I'm not an expert on this, but is Zeus, the god Zeus, grabbing a bear by its little tail, swinging the bear above its head, stretching it out, and tossing the bear to the sky to form the stars. The idea of a bear with a tail was known artistically since the time of Ptolemy, when he created the first recorded astrosphere of skysphere and documented the bear with the tail. But bears don't have tails. Bears have never had tails. If you want to find a bear with a tail, you have to go back about 1 million years in evolutionary timescale to find a bear with a tail, and that's really more like a badger or a big kind of a fox. So the fact that we have this constellation of a bear with a tail removes it from our own kind of relation. And when you think of the story of Muin, it actually tells us the time in the year and changes the year, whereas Ursa Major with the tail tells us nothing about nature or life. It tells us about Zeus and his ability to stretch tails. So that's my rant. Thank you for listening to the rant. I'll continue on back to the regularly scheduled talk. This is also important because it links the sky to colonization. When the International Astronomical Union sort of defined the 88 constellations that map out our sky over a century ago. In doing so, they ignored the knowledges of the land that we're on. They also erased a whole bunch of other constellations, such as a typewriter. That was the one, if I remember correctly. But in doing so, when this was done, we erased or attempted to erase our story of Muin. Because when we go to schools, when we learn the constellations, we see Ursa Major with the tail, and it hides away. So the sky in this respect is linked to how we colonize the land and how we learn from it. So I also want to take this point with what we learn, and we've sort of seen how traditional indigenous knowledge systems can tell us different ways of understanding the constellation and its movements and live within it. And I just want to actually hammer home the idea that traditional Western science on the right bullet is very different, or can be different. Doesn't make it wrong, doesn't make either wrong. I mean, really, we can use both of them together to do some really interesting studies. But for indigenous peoples, knowledge is relational. In traditional Western science, knowledge is objective. Western science wants to reduce knowledge to the smallest number of variables. We want to do a correlation of two variables every time. Indigenous knowledge is typically multivariable, all kinds of nonlinear behaviors. Western knowledge is siloed, holistic. The one that I think is kind of most important for what I want to talk about life in the universe is how we view nature. In the West, and this is really tracing back well beyond what I would call traditional Western science, is nature's hierarchical, and that humans are elevated above nature. And we see that in society all the time with how we treat hunting, landscapes, waterscapes. We treat nature as if it belongs to humanity, as opposed to indigenous cases where we're all equal partners in the prospect of having a natural world. And so in that case of nature being equal, we're not above it. Our definitions of various things will change. So I want to explore with you, and I've never actually discussed this publicly in a public talk, so I can derail myself pretty quickly if I'm not careful. I want to ask, what does this mean? If we take these two knowledge systems and we ask the question, what does this mean for the question of life in the universe? With the sheer fact that we know, at least in Western science, as far as we know right now, we're the only one. I mean, phosphone on Venus sounds pretty cool, but we don't really know of any life on any other planet. I would also kind of note, depending on which nation you are, for instance, if you are Cree, the Cree are star people. That by their own definition, they are star people. They come from the stars. Some people might treat that as being equivalent to Carl Sagan's quote of "we're all made of star stuff," or some might be more literal and say they were brought here from another star. So for them, life automatically exists elsewhere in the universe, if you follow that path of logic, or it could mean that. So let's ask this question of, if we were to look at it through indigenous lenses, what does it mean for the question of life? So I just want to remind you, and I'm sure you've all seen this equation in one form or another, the Drake equation. Probably for most young people today, that's a very different equation and involves rap music. But for astronomers, the Drake equation is a thought experiment asking, what are the conditions about how many quote unquote civilizations there might be in our galaxy? And the idea is to break it down into different quantities and sort of estimate what we can understand about each of those quantities and sort of give a back of the envelope kind of guess how many quote unquote civilizations might exist. So the idea is fairly straightforward. And I quite like this kind of slide that I stole somewhere off the internet, that the number of civilizations is n. We know n is at least 1, because we can communicate, we talk to ourselves all the time, but we don't know what n is greater than 1. And understanding this, we need to understand things like how many stars form in our galaxy every year, What fraction of stars will end up having planets, which today we know is a lot, maybe probably 20% or more. The average number of planets that could potentially support life per star. So if you have a planet, could it, might it? Well, that's a bit of a tougher question. Then there's the fraction of stars that can go on to have life, or the fraction of planets that can support life, that actually do support life, because there's so many things that can derail that process. Then the next one is the fraction of those planets that support life to support intelligent life. Well, that's an interesting kind of term. Then it continues on. What's the fraction of those planets that support intelligent life that create civilizations that can develop technology that is detectable? And then finally, there's L, which is the length of time such civilizations will release detectable signals. Now, when Drake originally created that equation, L was sort of dictated by the Cold War and the fear of nuclear annihilation. For many people today, the fear of L is sort of dictated by the fear of irreversible climate change destroying humanity. Or L could just be, we lose interest in radio signals and we move on. But all in all, we want to look at all these variables, and we can come up with all kinds of numbers. We know the average star formation rate, number of stars per year, is about 3. The fraction of stars with planets, probably 20%. 1 in a million, 1 in 1,000 maybe can potentially host life, and so on. And we can come up with some numbers, and on average, you usually get between 1 and 100, based on our best educated guesses. But let's think about some of these definitions. What does it mean to say you have a planet that supports life? What does it mean to say it's intelligent life? What point does life go from non-intelligent to intelligent? What point does intelligent life release signals that are detectable? I find this kind of a term kind of funny because right now, humans are on the verge of being able to detect biosignatures from planets around other stars. So we don't actually have to worry about detecting radio signals or infrared radio signals or see Dyson spheres. Maybe we can see ozone. And that is an evidence of life, potentially. And so we get close. So that kind of number changes a lot depending on how we define it. And of course, the length of time depends on how we live on, how one lives on the world and how one develops. So let's think of these questions. How do we define life, intelligent life, and civilization? Now, there's a number of good definitions for how we define life. But every time we do it, there's always a caveat or an except. For instance, life should be reproducible. Well, how do you define a crossbreed that can't reproduce? Is it alive, like a mule? Or life should be able to ingest things and create energy. Well, viruses don't work quite that way. You know, is a virus alive? Is COVID alive? So every time we have a definition, it's a little bit iffy, but we have a pretty good hold on. We're pretty sure we recognize when something's alive when we recognize something is alive. But the other two questions, intelligent life and civilization, that's a little bit more difficult. So let's think of it this way. Based on, I would say, our traditional Western thought, in the construct of the Drake equation, I say we as in the sense of Western society or what is nominally the Western ideal of society, is the intelligent life, is the civilization. In a world that is with 7 or 8 billion people, that's a very distinct way of looking at it. And because most cities, large cities, are starting to look like billboards and towers, that's probably not that far off. But what happens if we shift from this Western perspective to Indigenous perspectives? How do those definitions change? So I'm just going to throw this out there. I have no real good evidence to say this one's more right than the other. But I want us to think about how does our view of the Drake equation change if we think about these definitions through different lenses? So we know when we look at the tree of life from biology, where you start with eukarya, prokarya, bacteria, and you break it down, and you get humans, you get reptiles, you get other mammals, you get fungi, etc. That is very diverse. I mean, we're seeing the diversity of life every day in different ways. Even though we are at the greatest rate of extinction ever, we're still discovering new life that we have never seen on Earth before. And however, the definition of intelligent life is limited to one species, humans. And if you're from the Western perspective, you might argue humans are intelligent life because we have the ability to do X, to either use tools, to send signals, to compose poetry. You know, everybody can come up with their own definition, and there are many. But for many indigenous peoples, life around us are related to us, and they have their own spirit and their own knowledges, whether it's the raven in some nations, whether it's the bear in the Mi'kmaq tradition, whether it, you know, depending on whatever it is you want. So why aren't animals intelligent life? As I mentioned, from a Western perspective, we could detect biosignatures, we could detect anything that respirates carbon dioxide and uses oxygen, and therefore creates an oxygenated atmosphere, or sorry, anaerobic, we could detect the result of anaerobic evolution, where oxygen is released to the atmosphere, creating an ozone layer and allowing for the evolution of mammals that can live. That doesn't mean they have to be humans. Is that any less intelligent? They have their own place and their own fit within nature and society and their own societies. Numerous studies find societal impact behaviors between killer whales, between dolphins, and primates. I mean, intelligent life is a very concentrated and very egotistical or human-centric definition. And I think the other issue is the idea of civilizations. And I always find civilizations kind of a crummy phrase. I guess partly as an indigenous person seeing colonization, the idea of civilization is really being made European. You know, when European, English, French, Spanish conquerors came to North America, they were civilizing the indigenous people. When we had residential schools, it was to civilize the indigenous peoples. But ignoring the kind of grossness of the word, how long do they last is a different case. As I mentioned, when Frank Drake wrote his equations, the biggest worry was nuclear annihilation. Today, the big worry is climate change. So we got 10 years before it's irreversible. So does that mean we got a 200, we could say civilizations last 200, 300 years? Well, if we look at it a different way, when Canada 150 happened, one of my favorite memes came up was Mi'kmaq 13,000. That the Mi'kmaq people were in Atlantic Canada for upwards of 13,000 years. And we could trace that further back. Indigenous peoples have been in North America for at least 13,000 years and probably closer to 17,000 and 18,000 years based on Western archaeology. Do we consider that a civilization? If so, how do we emit detectable signals in space? Do we do it through our relation with nature? Do we do it with our relation of modifying nature? And thinking about these issues is very important because, you know, if an indigenous society lasts at least 10,000 years versus a few hundred years, you know, that's 2 orders of magnitude more planets that could have life of that type. So how does this all change the idea of advanced civilizations and numbers? And I don't know. The honest answer is I don't know. But I would look at it from a different perspective. We have to remember that number of civilizations is very much defined through a specific lens. And based on the dictionary, the stage of social and cultural development organization that is considered most advanced or technologically advanced. Well, why? Why does that have to be the case for the Drake equation? So I would sort of suppose in this kind of discussion that if I would go back to the Drake equation and I throw in different indigenous axioms of knowledge and I rethink of how long civilizations can last and what is intelligent life, we don't go from a galaxy with maybe 10 planets teeming with life. We go to thousands, tens of thousands, hundreds of thousands. And we haven't done anything to actually discuss the actual number of planets in our galaxy or the actual number of planets that might support life. We're just looking at vague definitions within science. And it's not, and I think it changes how we should view our night sky and how we view the galaxy in that case. Because life is a whole other different thing if we are more inclusive in how we define things in the Drake equation. I kind of want to take a second and shift because I want to talk to the other annoying word in astronomy, which is colonization. And what does this idea of life and life in the universe tell us about colonizing other planets? I mean, I'm sure many of us are big fans of SpaceX and being able to send a rocket up into orbit and to bring it back down and land it. That's amazing. But I'm not really interested in Elon Musk bringing people to Mars and settling down and building his Martian mansion. It's a different story. From a traditional Western perspective, you know, the evidence for life on Mars is basically nil. We've seen potential evidence through meteorites on Earth, some evidence potentially through methane plumes off the surface, maybe, we don't know. It's all very hazy evidence. But for the most part, we treat Mars as if there is no life. And this idea of going to Mars because as no life really is almost a century old now, but at least from literature. But the first scientific endeavor goes traced back to Wernher von Braun, when he became the engineer to design the U.S. rocket program. He built a technical spec for how to send people to Mars. He wasn't planning to go to the moon. He wanted to go straight to Mars. Yeah, and so that idea has been around for a long time. And today that we view that kind of as the frontier of exploration, the next step for humanity, the plan B for when we really screw up this Earth. There has a romantic notion in that Mars is almost the Wild West. In many cases, many people, when they make cases to go to Mars, use the Wild West as an example. However, the Wild West wasn't the frontier for Indigenous people. It was home. It wasn't wild, it was home. Is Mars any different? And let's be honest, it wasn't that long ago that this wasn't the frontier of exploration. When we had genocide by Columbus, Giovanni Caboto, Cartier, and so on, landing, planting flags, this was the frontiers. And it became the frontier especially when it was decided by European powers that this land in Australia, New Zealand, and Hawaii, and many other parts of this world were declared terra nullius. It was nobody's land, even though people were living on that land for thousands of years before Europeans. This was a political trick. If you say nobody owns the land, you can claim it. And Europeans did. Are we going to do that with Mars? Are we going to declare a Martian nullus? Are we going to send a whole bunch of rocket ships and plant a flag for Musk land or the United States or United Arab Emirates or China? Are we going to, we're having trouble respecting non-territorial claims in Antarctica. Are we really capable of doing that in Mars? And of course, for those who want to go to Mars, the dream is to terraform. It's like in that old, I shouldn't say that old, in that Star Trek Next Generation episode, where the terraformers on the planet and are killing life that exists there that they just didn't recognize. Do we have the right to take away the land? Does the land on Mars have its own rights? Does it have its own life, living subsurface that we don't know about? So if we go to Mars, are we contaminating it? Are we damaging it? So I just want to leave you here with these thoughts. I guess this really wasn't a traditional astrophysics talk, not really supernovae and Big Bang, but I hope that I gave you a sample of what it might be like to look through the universe through another person's eyes, and to think about what life might mean on other worlds and what rights we have as a Western dominant society to do leadership and to push for these things, and how we can perhaps be more inclusive to all those different peoples. So with that, I'll say Walalia, and thank you. And I'll be happy to answer any questions or hear any thoughts you have.
That's wonderful. Thank you very, very much. And I'm sure some people will have some questions, and we'll certainly get to them. I enjoyed that very much. Last, I think it was a couple of weeks ago, I participated in the NASA Space Apps Challenge. I was running hosting a seminar for them. And it's a variety of post-secondary students that were engaged in a series of activities and challenges, space-themed challenges. And I found myself hosting this seminar that ended up revolving around the Drake equation. And I didn't expect to find myself in that situation, but it was terrific, because first time I had the opportunity to talk about the Drake equation in a classroom was about 30 years ago. And one of the things that's really nice about it is how much we've changed the answers to some of those conditions in the equation over that 30 years. It was very nice to pin some actual numbers on some of those things, which we couldn't do back then. But in talking about it to these students, these post-secondary students, one of the things that was really, really encouraging is when we got, and this is one of the really fun things about it, right, is we got hung up on the definition of life and the definition of intelligent life. And these people, in the end, I was pleasantly surprised, because they absolutely refused to get pinned down on a conventional definition of intelligent life. They just wouldn't do it. They were far more broad-minded than I expected them to be, and that was really marvelous. I was delighted at the end of the session to walk away encouraged and pleasantly surprised by some of their approaches. So that was just fantastic. Thank you. Sue, do we have questions from people?
I don't see anyone with their hand up or any questions in the chat at this moment in time. Maybe we'll give people a minute to ask. Julia, Julia has a question. Julia, do you want to turn on your mic and ask your question, please?
Yeah. Hi. Living in Hamilton and going to the McMaster Planetarium, we've heard the story of hunting the bear here, and it also has that same geographical positioning. And I'm wondering if you know of lots of other Indigenous stories about the stars that are really geographically centered in their own place, and how people learn those stories.
So in terms of I'll speak to the bear story, it's an incredibly common story. It's actually across the entire North. The bear story persists, whether it's in Greek, various other European cultures, various Russian Indigenous, various Indigenous across Canada. There's a Cree story that's almost identical, different birds, but the story is effectively the same. It's fantastic, wonderful how the bear story persists. Another issue that's quite common, and it's kind of a funny one that I still don't have wrapped my head around, is the Pleiades. You might ask, how many stars are in the Pleiades? Well, if you ask in almost every Indigenous story, it's always 7. It's always 7 sisters, 7 children, 7 warriors, 7 hunters, 7. And in fact, I was in New Mexico a year ago and got to speak with a Navajo elder who was telling me about the Pleiades and how there, one of the stars in the Pleiades is very hard to see with an unaided eye. So historically, they would bring the young children out into the nature where it's very dark, and they would point up to the Pleiades and ask them to whisper in their ear how many stars they see. A lot of children would say 6, a few would say 7. The children that said 7 would become the warriors because their eyesight was much better. So, a lot of stories have elements that are related across. Even the Pleiades stories with number 7 stretches from Indigenous Australia through Haudenosaunee land here, and so on. And it's a very strange kind of phenomenon. One possibility is that many of these stories are related from stories that are as old as migration. I think I've forgotten your second question.
Hilding, if I can speak on Julia's behalf, I think she also asked about if you were aware of any resources or places we could turn to learn more about this. And I will second that because I'd like to know too.
So resources are in many different places. The Cree stories. One place I would invite you to explore is look up Wilfred Buck. He is a Cree educator in Manitoba, and he's not a professional astronomer in the academic sense, but he has a portable planetarium that he carries around to various communities to teach children and Indigenous peoples. And he has written a book on Cree stories. So there's the Cree story of the bear, the Cree story of the 3 dogs, which is a beautiful story about how dogs came to be part of Indigenous life, and many others. If you look on a website called nativeskywatchers.org, Professor Annette Lee in the US has written 2 books, one on Ojibwe or on Anishinaabe sky stories, and another on the Dakota stories, for instance. So, and then there are other books. There's a book called The Arctic Sky, but we don't have a central repository for these stories. One of the issues with a lot of these stories has been colonization. I'll relate to the way that Wilfred Buck put it to me and a group of us a number of times ago was, if you imagine that your nation, your community all shared one word of a song, then you had waves of colonization. People died from disease, residential school, war, famine. So eventually 90% of the people are removed from community one way or another. So you only have 10% of the words of the song, and you're trying to rebuild that song. It's not easy. A lot of stories have been lost. And I think it's been a challenge to try to find connections with these stories. And there's also the reality too, that for many Indigenous people, a lot of these stories are meant for sharing with the outside world. There are stories such as the Winter Maker for the Ojibwe or Cree that is only supposed to be told when there's snow on the ground. So, it's not a story that would be appropriate for me to share here, though you can find it online. But there are a nice number of resources, and I have a copy of Stars of the First People too. I have, if you look me up, if you Google me on medium.com, I have a reading list of different books of different topics related to Indigenous astronomy. So you can actually find a reading list there as well.
Thanks, Hilding. We have another question from Doug Turner.
Hi. Actually, one of my questions has already been answered, so thank you very much for that. I'm intrigued by your idea that knowledge is relational, and I'm sorry if you've already answered this because I had to get. I was helping another person in the meeting, but would you mind expanding on that thought just a little bit? What exactly do you mean by when you say knowledge is relational?
Yeah. So from a Western perspective, let's say I observe a star and you observe a star. And we see it's the same star, but you'll observe it one way, and I should be able to observe it the same way. In a relational sense, let me rephrase that. In that sense, we're looking for objective knowledge, things that are intrinsic to the star that don't care about us. In a relational sense, what we see in the sky is related to us. So we see things from our perspective. Somebody else might see from a different perspective, or the knowledge relates specifically to the location you're observing it. One interesting way of kind of thinking about this is the cosmological anthropological principle, in which we live in a universe where all things like the force of gravity versus the strong atomic forces are so well defined that if any small changes in any of the four forces means our universe can't exist in the way it does, and we can't exist. And so the fact that we exist in this universe with these behaviors so perfect is a problem for many scientists. And so from an objective sense, well, maybe there's a multiverse where all these different possibilities exist and we're just in one. From a relational sense, we don't need that. We only need one universe because it's only the universe we relate to. And of course, the parameters have to be the way they are or we wouldn't exist. And so we're related to the universe in that respect. Does that help answer it at all? I think I almost confused myself on that.
I think so. So maybe I'm incorrect, but you're saying that any epistemological system has to take into account the perspective of the observer.
That is a very scientific way of putting it, yes. So quantum mechanics would be a very way of doing this. If you ignore probability, the observer sees different things.
Okay, I think I'm getting the hang of this. Thank you.
Thank you. John, at this point in time, there are no more questions, so it's over to you.
Good. Thank you, Sue. I appreciate that. I'll tell you, Hilding, that have enjoyed this very much. I very much like the interdisciplinary approach you take, and I myself actually started out with an educational background in art and ended up teaching astronomy. And I'll say it to you, I'll say it to the others here, and I've said it to many others in the years in between. It's amazing how useful such a radically different educational background it has turned out to be, not just to draw upon in terms of examples and that, but to give me the opportunity to form more unique perspectives that often I don't come across in other ways. One of the things I got to tell you too is there's absolutely no need to apologize for your rant about Ursa Major's tail. No need to apologize for that at all. I have, and those of you here in the group that have seen me do talks and that out there, know that I have often made jokes about Ursa Major being the world's only long-tailed bear and how ridiculous that is. So please don't apologize for that rant. I think everybody here is totally on board with you there. So Hilding, I cannot thank you enough for coming and joining us tonight, for sharing this wonderful talk. I'm seeing comments pop up here and they're all positive. And I'd like to add my own to that. Absolutely wonderful. Thank you very, very much.
Thank you for having me. It's been delightful to come and speak to your group.
So excellent, excellent. So, all right, everybody. We have other things on the go here, and Sue has asked me a question. I'm just going to answer her verbally right now because I can't type on here and talk at the same time, because that's asking too much of me. I can't even I can't chew gum and walk at the same time. So the answer is 4. The answer is 4 door prizes. So 4 of them. Okay, so here's what we also have on tap for tonight. Now that the highlight of the evening is over, we have some other stuff to do. This, of course, is October. It's our annual general meeting in which we take care of a little club business. We have door prizes to hand out, and we have Matthew Mannering to give us the sky this month later on. Let's see, how are we doing here time-wise? So what we'll do is we'll take a brief intermission. Sue, right?
Yes.
That one? Yeah, we'll take a brief intermission now. We'll come back with the business, the door prizes, and Matthew after that. And we will come back. Sue, what did we do last time?
I think considering the time, let's make it about 5 minutes.
There you go. Look at that. I got the big 5.
So I can read your mind.
5 sounds perfect, everybody. So 5 minutes, we'll reconvene and carry on. And once again, Hilding delighted. So see you all in 5. Feel free to chitty chat amongst yourselves.
You do have 5 minutes. If you would like to turn your cameras on and your mics on, you can go ahead and chit chat. And John will be back in a couple of minutes.
Is Bob Christmas there?
Bob Christmas is here. I saw him a little bit ago. Bob, chirp up.
Thanks, Jim. No, I just want to tell him if he's listening, thanks him very much for Event Horizon. I haven't had time yet to get into it, and I haven't had time to archive it, but I will do so.
You're welcome, Mike.
Thanks again, Bob. You do a great job with it.
Good to hear you, Mike. How you been?
Oh, fine, thanks. My camera's not on because John told me to turn it off, so I've turned it off.
You can turn it on now, though.
Can I? Okay,
We'd love to see your face.
No, you wouldn't. It'll crack the lens.
Oh, well.
Here we go.
Break my computer.
Everybody is welcome to have their cameras on right now, Michael. I only mentioned it to you before while the speaker was talking so that we were able to focus on the slides and not on the view of you from your camera. Everybody could focus just on the speaker's slides. That's all. But you're welcome to have it on now.
15.
Well, you should all know that mine and I are in the top secret business right now of doing the draw. So I'm going to turn the mic off.
Hello, Michael.
Come on, Michael, answer him. This is an old friend of yours.
Nope. Hello? Who is it?
A blast from the past, Michael.
Oh my gosh.
You don't have to be formal, Michael. Don't call me God with these people.
Now I recognize you. Yeah. Yeah.
Has it been a little bit of water under that bridge, Michael?
Yeah, I guess. I thought you were washed out into the Atlantic with the last big tide.
Well, actually, I'm about 300 feet from the Atlantic here. Well, a little inland, anyhow.
What's the weather like tonight?
It was very nice, really nice. I was out in a t-shirt photographing today, walking through the woods. Beautiful day.
Really?
Yeah.
No, I thought it was a little cool around here, but hey, it's that time of year.
Well, Nova Scotia is a funny place. It depends on where you live, what the weather's like. We just happen to live in an area that's really quite moderate compared to the rest of some places, anyhow.
Okay.
Yeah, it's well, for example, I had a guest here once, and I told him a story, and he thought I was full of baloney. And we were sitting on the deck having a drink or something. It was about 18 degrees at the end. So I took him for a little drive, and we went about 15 kilometers to a beach, and we couldn't see our hand in front of our face. The fog was so bad, and it was 13. And then we drove an equal distance inland and the temperature was 32. So this is all within about a 7 or 8 kilometer radius. It changes very drastically. So when you hear the news about how bad it is in Nova Scotia, you got to realize where it is in Nova Scotia. They're telling the news. Yeah.
Well, it is a maritime environment.
Yeah.
And I know exactly what you're talking about. I've been caught at night in a snowstorm in a boat. It was scary.
Yeah. I think we've been here about 13, 14 years. We've only had 1 year with massive amount of snow. Most time it's pretty mild winters. It drops about 2 degrees below freezing. That stays that way.
Well,
Our seasons are, because of the water, our seasons are switched. So we won't have snow for Christmas, but we will have it for Easter.
Oh, okay.
Yeah.
Yeah. Well, nice to see you. Nice to hear from you.
Nice to be able to say things at my age.
It's nice to see you again, Grant.
How's Gary?
I haven't seen Gary for about maybe a year with the COVID and all that. Gary's very active out here. Gary's other love was music, and
Right.
he has taken on. We have a number of major musical festivals in Lunenburg. One of them being a folk festival, and Gary's one of the leaders in that. And we bring in. We have I don't know how many. We bring in thousands of people to see this thing, and hundreds of performers. And yeah, he's been involved in that. Matter of fact, he got me a job working with him, taking pictures for a couple of years. Yeah, Gary's. People don't know Gary, maybe. But, yeah.
If you're sorry.
Oh, go ahead.
If you're talking to him, if you're talking to him, give him my best, please.
I will.
Thank
He only lives about 15 minutes from me.
Okay.
I didn't realize that's where he had moved in. Yeah. That's Gary Woodcock, for those that don't know Gary. He was on.
Gary and I exchange emails every now and then. We send photos to each other. Every now and then I'll get this very lengthy email with about 20 photos attached to it. And he sends these to me and says, John, I know you know your way around a camera, so you'll appreciate this. And then he tells me all the technical stuff about the photography and all of that. And it's wonderful. I was delighted because Gary is one of these people who does everything well. You know, he's just everything he puts his hand to, he masters. And he's a wonderful photographer, and I do appreciate and enjoy those emails that I get from him and a chance to see his photographs. Just wonderful.
Oh, he's a pillar around here. Gary and I actually, we were involved with, I think it was a 4 or 5 man photographic show in a local art gallery down here. So yeah, I worked with him in that. The funny thing with Gary, when I moved out here, I actually thought Gary was on the other coast, and I came to Nova Scotia. I had a new place, don't know anybody, going to start out all new. And I got invited to a kitchen party, which are very popular out here, where they have musicians. Everybody kicks in a few bucks. And this place, about 70 people could go to this. I walked in and there's Gary. This 2 days here to meet somebody. I thought I had escaped everything. No, I hadn't. You can run, but you can't hide.
John, are you ready to go?
I am ready to go. So
okay, so we need people to mute their audio, mute their microphone, and turn off their video as well, please. And John will get us back on track.
I certainly will. And I will say this in front of everybody now. It's a pleasure to see so many friendly faces and some new ones, including Grant. And I said these wonderful things about Gary's photographic abilities, but Grant knows his way around a camera too. And I have seen some beautiful images come from the hand of Grant. Just wonderful. So we have so we have some business to take care of. This is the October meeting, and we're going to do the do the obligatory business work that we have to do here. I am going to ask, because I am obliged to do so, if there is anybody in the audience here who would like to, who hasn't already spoken to me, anybody fresh who would like to rise from the floor and stand for council. And we'll just listen to the crickets chirp for a minute. And if there are no other takers, then I'm going to announce that the council for the 2020-2021 season, and that's awkward to say, is going to be acclaimed and will be as such. It will, I'll read the names, but I'm going to tell you this right now, that it's just an absolute straight continuation from this year without any change at all. So the chair will be John Goverill, unless, and I'm giving you another opportunity here, unless somebody would like to speak up from the floor now, anybody at all. The chair will be John Goverill, and the second chair will be Jim Walmsley, and the secretary is Denise White, and the treasurer is Ann Tekach. The membership director is Leslie Webb. The digital platforms director is Christopher Stretch. The newsletter editor is Bob Christmas. The publicity director is Mario Carr. The public education director is Joanne Salsi. The observing director is Matthew Mannering, and the recorder is Brenda Frederick. And the councillors at large will be appointed by council at the next council meeting. And if anybody is interested in joining as a councillor at large, I encourage you to get in touch with me. I would be very, very happy to talk to you about it. Very happy to answer any questions you might have, and very happy to welcome you to the group. All right. Does anybody, because we have to do this at this time, does anybody have any reports they would like to make? More crickets. My goodness gracious.
I will have the financial statements prepared for the EH by the December issue.
Right. And that, of course, is because our year ends on November 1st, and this, of course, is in preparation for that transition on November 1st. And so Anne, of course, can't give the year-end financials yet because we haven't yet come to the year end. But once that happens, she'll complete those in the following month, and they'll be available in the newsletter, and everybody can review them there. I am going to make just a couple of remarks here. This will be very quick, but I do want to just say a couple of things. This has been a strange year for the club. It's been a strange year for everyone on the planet. The club has had to adapt by instituting some changes in how we do things, and we are still transitioning and still learning how to best use our new format. I am pleased to say, though, that so far the transition has been relatively smooth. We are enjoying some wonderful speakers like we had tonight, last month, next month. The online meetings are going well. We are getting out and observing more now as well, and that's great. And soon we hope to begin the beginners group series of seminars in an online format, very much like this. We'll have expanded discussion and chats rooms after the monthly meetings as well, coming up soon. In the meantime, I would like to draw attention to those who have worked hard to keep the club going in its new iteration. Our online presence has expanded largely thanks to the work of Christopher Stretch, who has added lots and lots of new material to the website and keeps our social media up to date. And that is no small task, as our presence and existence has relied on that much more heavily lately. Chris has also helped a lot out with these meetings here, but a big vote of recognition goes out to Sue McLaughlin, whose voice you just heard a moment ago, who is the mastermind behind the scenes of these monthly meetings. You can tell that because you can tell by how many times I call on her and ask her questions during these. So I get to sit here and talk, and you look at my face, but Sue is the person behind the scenes making all of this happen. So Our newsletter is another way in which we are highly visible, and it is as good as it has ever been, with great contributions from many members. Hey, is Alex in the meeting here tonight? Outstanding masthead photo this month from a relatively new member, Alex Keppett. And it's put together by our editor extraordinaire, Bob Christmas. So I can't say enough good things there. You have not seen the results yet, but Doug Turner has been working tirelessly on the calendar. I had the pleasure of seeing the photos that were submitted for the upcoming year, and they are outstanding. I was so impressed with the large number of good photos. He could easily have put together 2 calendars out of all of the good images that we have. Next month, as usual, the calendar will be available and we will be showcasing the images. Joanne Salsi has been handling the club's outreach for the past couple of years and has done an extraordinary job, and remarkably has found a way to adapt it, adapt some of the programs to make them safe and fun during this pandemic. I don't think I could have found a way to do the things that Joanne has done. She continues to give to the community on this club's behalf, and that deserves a lot of recognition. You also just heard from our treasurer, Ann Tkach, who not only keeps our books in order, which is a huge job, but also acts as a liaison to McMaster Innovation Park, our past and future venue, he says, hopefully. And Denise White is the club secretary. She sorts the mail. She makes sure that everyone is aware of what is going on, and will again be manning the library once it's safe to distribute books again. Mario Carr is our publicity person, the author of some wonderful newspaper articles, and you really, really need to watch him on CHCH if you haven't been watching him already. You can find past segments on YouTube, and they are so worth watching. Leslie Webb is our membership director, organizes the membership list, keeping everything sorted. And Brenda Frederick is our diligent note taker, recording all of the business that the club transacts. 2 more names on this month's list. Next month is a different one. 2 more names on this month's list. Jim Walmsley as the second chair, traditionally runs the Telescope Loaner program, makes the trips to the food bank for us and that. But as second chair, even without being able to do those things in these days, he's ready to step in at a moment's notice to take my place, should I become available. I know you're all hoping that day will come. And of course, just because we aren't gathering in person and aren't collecting for the food bank, please don't let that stop you from making contributions yourself. You can give directly, all right, to Hamilton Food Share or whatever food bank is available to you. Please don't hesitate to do so. And finally, Matthew Mannering doesn't need me to tell you about all the hard work he does. You get to see it yourself every meeting, read it in the newsletter, and you will get to see Matthew give his presentation to you in just a couple of minutes. I can only tell you that I very much look forward to his talks and articles every month. And like the rest of those that I have just mentioned, it is an absolute pleasure to work with him. Next month, we'll talk to the councillors at large who will be in place by then. Once again, anything else? Any other reports to mention? No, okay. All right, in that case, we have door prizes to hand out. The door prize, so do we have our door prize distribution team here? Yes, there we are. Hello, family Whitman. Hello, Melissa. Hello, Maya. Great to see you.
John. Hello, everybody.
So wonderful. And Maya, you're ready?
Yes, I am.
Excellent, fantastic. So we have 4 books available this month. The 4 books have been donated by Joanne, and a big thank you goes out to Joanne for her generosity. All right, since the club stash is not currently available to us because of the pandemic situation, A big thank you to Joanne for her contributions. Here's what we have available to us tonight. Uncovering the Secrets of the Red Planet Mars. Fantastic. It's a National Geographic book. It is loaded with I can't do this. Loaded with beautiful, beautiful images on other pages, apparently. There's some. Lots of info, oh, so nice. Lots of stunning images. That is one of the books up for grabs tonight. To the Edge of the Universe, the Exploration of Outer Space with NASA. Another nice coffee table book with lots of nice illustrations in it. We have a theme. This is a really nice book, actually. It's called Space, A History of Space Exploration in Photographs. It's in the title, so you know this one has lots of nice photographs in it, all right? So this is actually lovely. This is a beauty. I really like this book. This is very nice. And I really, really like this book. In fact, I have a copy of it myself. It's called Space Places, another beautiful coffee table book. And this has stunning images of all things space related, not just space exploration and that, but there's a variety of observatories and that in here that just makes it wonderful. These are the 4 books that are available to us, to you tonight. So here's how we're going to do this. The books, as you can tell, are here at my house right now, and they will be available for pickup here at my house. If you are a lucky winner, please feel free to get in touch with me, and we can arrange a time to put these in your hands. All right, will be touch-free kind of thing, so absolutely 100% completely safe as we transfer these to you. So, and what we can do, Maya, you tell me what you think of this. I am very happy to risk the stampede for my door by saying, here are the 4 winners, and the first person who shows up here will get to pick the first book out of the book box. So that's one way of doing it. Or do you think we should let them pick now, and I'll write down a name to a book? What do you think?
It might be a bit difficult for them to pick now because they don't really have the book in front of them, right? They can't really, flip through and look at it to see which one they really want. So first option would probably be better.
Exactly. So,
and I need a webcam so we can all watch the stampede is in order.
Yes. Okay. So sounds good. All right. In that case, I hand it over to you, Maya. Let's see who tonight's lucky winners are.
Get away.
So, as we did last time, I have rolled our percentile dice. And we have come up with 4 names from the list of participants. Number 1 is Swapna. Is that how I say that?
Yep. I know just who you're talking about. Fantastic.
Okay.
Swapna, congratulations. You're a lucky winner. Who else have we got?
Our second name is Annika.
So, excellent. Winners feel free to turn on your microphones if you like. Is this the Anika that was out observing a couple of weeks ago?
No.
Hi, this is hi John. Yes, Anika, who's in grade 7, was observing last week.
Yes.
Correct.
Yes. Fantastic. That's great. Good. All right. We have a book for Anika. Fantastic. So Maya, who else have we got? Maya, did we lose you?
I think we've lost them, John.
Oh my goodness. Okay, well,
But
when
you know
they
what? They will come back.
when they return to us, yes, we'll find out the next two names.
Yeah,
Well,
they'll come back in.
just to build up the suspense. So, all right. So you may think that we've orchestrated this just to keep you around a little longer so that you don't run off after the door prizes have been handed out. But that's not the case. So it's just going to work out that way this time. So all right. In that case, I will gladly proceed and hand the floor over to Matthew. Matt, are you ready to go?
Yes, I am.
Fantastic. In that case, I'm going to hand the floor over to Matthew Mannery. Matt is the observing director who does the monthly edition of The Sky this month. I'm very much looking forward to his presentation this month. I will put in a little plug here for Bob, who very kindly filled in with another excellent written column in this month's EH. But I couldn't be happier that Matt is here in person with us tonight. Matthew, I'll hand the floor over to you.
I'm going to interrupt before Matthew starts because Family Whitman is back.
Hello.
Hey.
Sorry. Turns out you have to plug your computer in if you want it to keep working. Oops. Who knew?
Okay. All right. In that case, Maya, you've got two more names for us, right?
Yes, I do.
Fantastic. Who else have we got?
So our third name would be Michael Jefferson.
Michael, excellent. Wonderful. And name number 4?
Tony, from Tony's iPad 5.
Okay. So great. So excellent. So thank you there's Tony. Hi, Tony. We have a book for you. So
Excellent.
my thanks go to Maya for doing a stellar job. I love that Maya goes old school and literally rolls the dice so that there is no chance that this is anything other than completely random. Well done, Maya. Thank you very much. Much appreciated. Congratulations to Swapna, Anika, Michael, and Tony. All of you need to get in touch with me. You know how to reach me via email, chair@amateurastronomy.org. You can reach me via phone if you have it. Email me. I'll give you my phone number, and we'll arrange to get those books into your hands. Congratulations, everyone.
Thank you, Maya.
No problem.
And Matthew, you still with us?
Yep.
Excellent. Matthew, now I'm happy to hand the floor over to you.
Okay, let's see what happens. Share the screen. Hopefully it works better than last month. Okay, can everybody see that?
Looks good, Matthew. Yeah.
All right.
Looks great.
Super. Well then, welcome to The
Yes.
Sky this month. My opening slide this month is actually done by my wife, Janice. Over the summer, she spent three and a half hour sessions trying to shoot M52, which is the open cluster there, and the bubble, which is just above it to the right. You can actually see the bubble in space. The bubble's a lot harder to shoot because it's extremely dim and it takes a lot of exposure. So out of the 4 nights, we actually only got one where we got really good data. The first 3 nights, we had the fires in California. We had extreme humidity in the atmosphere one night, and the other night we had extreme humidity all over the equipment. The water was literally running off of the scope and the camera and everything else. So the data wasn't bad, but you know, the 4th night we got 2.5 hours, and this is the result of it. They're all 3-minute exposures at ISO 1600 with her T5i and an 80 millimeter refractor. So it came out very nice. Jeff Moore's been doing planetary astrophotography for quite some time, and I can remember the first time he sent me a Mars picture, and I have to tell you, this is a huge improvement. And I really like this image that he has submitted. In fact, you can see what's left of the southern polar cap there. And here you can see clouds at the North Pole of Mars. And those clouds have actually spread and are all around Mars lately as the season changes. Now, he used an 8-inch SCT with a 2x Barlow. So he was shooting at the equivalent of 4 meters of focal length with his color planetary camera there. And Mars is very difficult to get good photos of because even though it's relatively close, it's also very small. So this is a nice job, really like it. Also apparently was heard my talk last month and decided that he would try and shoot one of the globulars I was talking about, M13 and Hercules. He's done a nice job here too. You can see the propeller, which you can actually see visually sometimes when you're looking at M13, but he also caught it in the photograph. And that's a really nice job as well. This was not Jeff Moore. It was the Keck telescope. And because Uranus is approaching opposition at the end of the month, just like Mars just did a few days ago, I thought I'd talk a bit about Uranus. Now, opposition occurs when you can draw a straight line from the sun right through the Earth to the planet in question, in this case, Uranus. So it's not necessarily at exactly its closest point, but it's usually within a week. And I don't know why there's that difference, so don't ask me that question. I thought I'd say a couple of things about Uranus. It was discovered by William Herschel about 240 years ago almost. 27 moons, most of which are really, really little, and a very faint ring around the planet. It's also laying on its side. So it looks like a bowling ball while it's in orbit, actually, as it goes around. The year there is 84 of our years. And because the planet is on its side, the northern hemisphere, as you want to call it that, gets 21 years of winter, and then half of a Uranus year later, the other side, the other hemisphere gets 21 years of winter. So really not a great place to live, even if you could. The day is 17 hours, 14 minutes. That puts it almost exactly right between the day on Jupiter, which is just under 10 hours, and our day at 24 hours. It's 4 times our diameter, but only 0.9 Earth gravity, which means that it's a lot less dense on average. And light takes 156 minutes from the Earth to get to the planet when it's at its closest to us. And that is right now at about 2.81 billion kilometers from the Earth. So if you're in the Tesla Roadster that's up in space right now, flying around, and if you had infinite batteries, then how long would it take you to drive to Uranus? Well, at 240 kilometers per hour, it'll take you 1,335 years without bathroom stops. So that just shows how far it is away. And what about Mars? It's a lot closer, 62.7 million kilometers, 3.5 light minutes only right now. That varies hugely, by the way, with Mars, depending on how it is with its orbit compared to ours. But even so, it'll take you almost 30 years to get to Mars. And that just points out the immenseness of the solar system itself, let alone going beyond the edge of the solar system out into interstellar space. Back in September, Janice and I and Les and Terry and Chris and Denise all went to Bacchus camping and to do some astronomy. There's a great field there, which was supposed to hold a star party this summer, but like the rest of everything else, it got canceled. But we went anyways, and the field is huge. The sky to the north, there's a light dome, but everywhere else is really nice and dark. And I just used binoculars the one night, and I was just bagging one object after another. It was easy peasy. So a great location really for some of us to go and do some astrophotography or just observing. It was really nice. And you can see Janice there. She was all dressed up in her winter clothes because it was about 1 Celsius when this picture was taken. And you can see the camera and the telescope are actually pointed at the bubble in M52. That's what she was shooting right then. Now on this image, which is just taken a few minutes later, the skyline looks really curved because I was using a fisheye, so you get this distorted perspective. But basically, the light in the trees there, that was a car that happened to be on one of the camp roads and just happened to catch that as it went by. Again, you can see that there's this light dome to the north and northeast, but there's Capella. There's the double cluster. There's Perseus. There's Triangulum, Aries, and there's Mars, just about an hour after it cleared the tree line. It was a lot of fun. We got very cold and very wet. So it wasn't ideal, but the sky, the one night, especially the last night, was really beautiful and well worth going. I was sort of just messing around with my equipment one evening, the good one actually. And this is just a single 2-minute image I took with my 900 millimeter scope with my T7i at ISO 6400. And all I've done is stretch it and saturate it a bit. And that's what I came out with. So that's pretty good for one image, and gives you an idea of how good the skies are there. There's a couple of events coming up between now and the next meeting. The first is on November 4th, about 9:30 in the evening. And at that time, the moon will be very, very close to M35 in Gemini. Now, M35 is one of the nicer open clusters in the sky. It's really very pretty, and it's worth looking at just visually anytime you can when Gemini is up. You'll notice that Gemini is just clearing the horizon, and so is Orion just to the right there. And that means winter is coming. So as soon as they're up, when you're still awake, it's bad news if you like being in shorts. But anyway, so have a look for that one. And currently, the Orionids meteor shower is occurring. It's a fairly long duration shower, and it peaks on the 21st, but you'll still be able to see meteors well into the first week of November. Now, they are not high volume showers. There's not too many. 15 to 20 an hour is pretty reasonable, but they're very bright and they're moving really, really fast. So they burn up really good, leave trails quite often. This image is really incredible. It's from Mongolia, of all places. But what I really like is there's Orion, there's Betelgeuse and Rigel, the belt there, Sirius and Canis Major, Canis Minor with Procyon. Over here is Castor and Pollux. This is Gemini going across here. This is Auriga up here with Capella. There's the Pleiades, Aldebaran, and Taurus there. And then there's just a ton of nebulae in this particular image. That's the California. This is the Flaming Star in Auriga. This one here is the Cone Nebula, and this is the Rosette. Down here is the Seagull, and in Orion itself, you've got Barnard's Loop. And this particular one up here, I'm actually not too sure what that is. I've tried looking it up and I haven't found a name for that particular nebulosity yet. But it's a spectacular image, and I thought it was well worth showing. And because Christmas is coming, and you know, it's always nice to think about things for Christmas, I thought I'd mention a few things. So this is a focal reducer and flattener, and what it does is it shortens the effective focal length of your telescope and flattens the field of view for astrophotography. So normally, if you're shooting at a fast f-stop, you're going to get stretched stars all the way around the edge of your image. This will actually correct for that and give you nice pinpoint stars pretty much right to the edge. I actually bought this one at late August, I think it was, so I've had a chance to try it once. I really like it. The coatings are very nice on it, and it was delivered to the door for under 200 bucks. And I would rate the performance as good, because you can spend $700 on a focal reducer and get excellent performance. But for the average person like me that is just, you know, doing this a few times a year, it's a great option. So it would, for instance, take a 600 millimeter refractor and make it into a 480 millimeter refractor, and gain you about half a stop photographically. So it just opens up options for any of your refractors. It gives you basically 2 refractors for the price of 1 and a bit. Now this is a lot more expensive, as you can see. This is for deep sky astrophotography, and it's a ZWO ASI 533 one-shot color cooled 9 megapixel camera. It's awesome. I've never actually seen one, but I have seen lots of pictures and I've read lots about it. The reason I like this one is that it's cooled and it's got a nice big square sensor on it. And the other thing about it is it has no amp glow. Now, this is what kind of glow you see on a long exposure with the lens cap on equivalent. All you're seeing is just the glow from the electronics within the camera. And that's what you would normally see in a 5-minute exposure with a lot of cameras. And you can see it looks like snow on the screen, like in the old TV days. This is the image that you get with this camera, the 533. The snow or the noise is very much reduced and absolutely zero amp glow. The other really good thing is you've got almost no read noise with this thing. So you can get full color images in very short amounts of time. You don't have to shoot really, really long exposures to get an awful lot of signal. And the signal to noise ratio is fantastic. So you can end up with pictures like this. And this is an example taken with the 533. It's the Pac-Man. And this is only 32-minute exposure. So 1 hour of exposures stacked. And to get this amount of detail and color depth and all this really things that make this a beautiful picture, it's pretty amazing. You could not do that with a digital SLR. There's just no way you'd get anything close to that. So if you're gonna look, if you're already doing astrophotography and you're looking at bumping up into a totally different class, this is something to look at. Another item is a pull master. So this is something else that I own and have used quite a bit, and Janice has used it as well with me. And it's used to align your equatorial mount to the North Star so that as the mount moves, it tracks the stars perfectly. And normally you do that by kneeling on the ground, looking through the polar scope and guessing as to whether just how close you are, you know, so you can be off by a fair amount. But with this, you can be within half an arc minute. And at that point, you can do 2-minute exposures with a 900mm scope or 3-minute exposures with a 500mm scope, which is awesome. I mean, you just normally cannot do that without a guide camera. So the way it works is this little doodad here fits in the hole in front of the polar scope on the mount. And then here's your camera. There's a lid on it right now. You unscrew and to see the lens. It pops in there, it goes by cable to the PC, and it takes about 5 minutes to get a super accurate polar alignment. We did 2 mounts in under 15 minutes at Bacchus Mills back in September, and they were dead on. So there are other options. One is a software like SharpCap, which costs $15 a year. The thing is SharpCap only registers certain drivers for certain cameras, so no digital SLRs. And the one guide camera it absolutely does not do is the Orion Starshoot guide camera. So guess which one of those guide cameras I own, which is why I have the Pull Master. And you can do it that way. There's other software you can use. And this is about $400. The Pull Master is not cheap. So if you were starting from scratch, what you might do is buy yourself a planetary camera, which doubles as a guide camera, which SharpCap recognizes, and SharpCap on their website will tell you which cameras it recognizes. And now you've got an actual camera you can use to do planetary as well as guide. So that's your other option there. And this is called a Batnoff mask. So it's used for focusing your telescope, especially for astrophotography. Now, normally the way we do it with our digital SLRs is we look at a bright star, and then we squint really hard at the screen and focus the telescope as well as we can. And sometimes you get it right on, and sometimes you're off just a touch, and that's enough to totally destroy your images. So this mask, which is absolutely really quite cheap, comes in sizes anywhere from ones that will fit on your camera lens, all the way up to 10 and 12-inch Dobbs or big refractors, anything like that. They're about $30 to $80 depending on the size, but you can go online and find tutorials on how to make your own by cutting it, you know, with an X-Acto knife, yes, into the plastic. Janice is helping me there. And or you can actually print them on a 3D printer. There's also plans, and the instructions for the printer are online. So you can actually make one for about 10 bucks. The way it works is that you end up with this set of whiskers, and you've got 2 cross lines and 1 vertical line. And that's the star that is creating through the mask. You're getting these whiskers. When you do it, when your focus is absolutely perfect, you end up like this with the vertical line perfectly bisecting the 2 crossed lines. And if you're inside focus or outside focus, which means you're racked in too far or racked out not far enough, you'll be to one side or the other of perfectly in alignment. And they work fantastically, but don't forget to take it off, because as Les knows and I know, that wrecks your pictures if you leave it on. So just use it to focus and then remember to take it off. 2 other ideas, red dot finders. Lots of people use them. I find they're used best, especially with a big daub, if you've got that, and you also have an 8x50 finder scope right beside it. So you use the red dot to get close, finder scope to put it right on the crosshairs, and then look in the eyepiece, and there you go. You've got your target. Other people like to use them just to do their 1, 2, or 3 star alignment on their equatorial mounts. And what it does is it just allows you to find that star really, really fast, takes all the frustration out of it. Magazine subscriptions are always good. Ones like the Canadian Sky News, I still get it. And I think it's a really great magazine. A hard copy Sky Atlas doesn't need batteries. You can use it anywhere, anytime. And one of the nicer ones that gets used a lot in the field by almost everybody is the Pocket Sky Atlas. And if your vision isn't that good, they've got the Jumbo Pocket Sky Atlas, which fits in no pockets, unless maybe you're an elephant and you got pockets or something. Otherwise, forget it. But it is really nice to use. Eyepiece upgrades. I'm referencing really the people that have their first scope, and you're using the eyepieces that came with the scope, which are always very basic. And it turns out that in most cases, the glass or the mirrors in your scope are much better than the eyepieces would suggest. And so if you upgrade your eyepieces just with a couple of them for, I don't know, 100, 150 bucks a piece, or just get one at a time, your view through your scope will be immensely better. You'll really see what the scope can do. That's what holds you back normally, is the eyepieces. And as we found out in September, thermal underwear is a really good thing to have. And considering where we're headed with winter, that's a great thing to buy and put it under the tree for somebody for Christmas. This is my last slide. I just found this last night on cloudy nights. This is an awesome image. It is 10 panels stitched together, total of 45 hours of integration. The integrated flux nebula over here, which I call dust, is about 6 hours per panel, and the nebulae over here are 2.5 to 3 hours per panel. The guy who did this spent the whole summer and early fall gathering the data, and then processed it as individual panels and stitched them together. Did an awesome job. The constellation is Cepheus, which is between Cygnus and the pole star. And there's a few things that you can recognize in here. That's the Garnet star, for instance, which, depending on how the atmosphere is, looks yellow to bright red in some cases for some people. There's the Iris Nebula, and it's just a totally awesome picture, and I can't imagine even trying to do this. So I just had to show it. It's a great last picture. And that's the end.
Wonderful. That's fantastic. Thank you so much, Matthew. Does anybody have any questions for Matthew? I'm sure he'd be happy to entertain any questions that you might have.
The answers might be entertaining.
My observing this past month has been almost exclusively Mars. I have had several absolutely mediocre nights with Mars, where the seeing has not been everything I've wanted it to be, but one or two really, really nice ones. And it's been on those nights an abundance of surface detail, the polar cap, clouds, the North Polar hood, just wonderful, just absolutely wonderful. It's been great. My other observing experience for the past month was I've told the story in the EH in the chair report, so you can look it up there. So did we have anybody come in with questions for Matthew?
I don't see any questions, but there was a question that popped up to everyone earlier in Matthew's talk, and I think we'll just address it quickly. The question was asked about looking where to purchase a good, decent starter scope. And I just replied back that KW Telescope is probably the best place to go to talk to people about purchasing a starter scope in the beginning.
Absolutely. That's one of my favorite places to go shopping. Very dangerous place for me to go shopping. Just love it there. And if anybody else has any advice, I'd be more than happy. I'm sure that they'd be more than happy to hear you out. I sent a private message to them, giving them my contact information, and encourage them to get in touch, because I'll be happy to talk to them about that as well. If anybody else has anything they'd like to pitch in, please do.
Joanne asked about getting through to Celestron and wants to know if anybody else has had that problem.
I have not had the problem because I have not tried.
And there is another suggestion in the chat that KW is a great place to buy a starter telescope.
Absolutely, and I concur. So very good. Thank you for pitching those in, people. So that should bring us to a close for the evening. I will offer thanks to Matthew for an excellent presentation. I enjoyed that very much. Lots of great tips to in there. Thank you, Matthew. Thank you to our guest speaker, Dr. Hilding Nielsen, for coming out tonight. That was fantastic, very much appreciated. Thank you to Joanne for her donations, for her door prize donations. Door prize winners, I've sent all of you a private message on chat with my contact info. You can get in touch with me so we can make arrangements to put those in your hands. Thank you to Sue for all the behind the scenes wizardry that you do to make this, to make these evenings work for us. Thank you to Maya for once again being the random element in our meetings and making the door prizes happen. And thanks to everybody else for coming out tonight. I think it was a well-attended and enjoyable evening. Thank you all for enduring a long meeting. Once a year, we have to go through a little bit of that business stuff, but it was, I hope that it was relatively painless for everyone, and that Hilding and Matthew more than made up for it. Thanks one and all for doing that. We will see you next month in November on Friday the 13th. What could go wrong then? We'll see you then, all right?